My name is Samuel Chukwu Emeka, as usual. In this video session, we shall begin solving questions on annuities. Please, it is highly recommended that you know the theory. So please view the videos on the theory before solving the questions. So here we shall just review the formulas that we've talked about, the formulas that we will likely use to solve questions before we now start solving the questions. As usual, we are going to be focused on a ordinary simple annuity. That is what we are going to be focused on, ordinary annuity. So we start with the first one. We start with a future value of an ordinary annuity. Let us list all the formulas that we may use. Okay, and I will write all these formulas before I define what they mean. We could have a M times PMT, then bracket 1 plus R over M exponent MT minus 1 all over R. The second formula that we might use, FV, is, this is the formula you see in most textbooks, this second one, 1 plus I exponent N minus 1 over I. But I prefer using the first one, it's easier. The third one, S angle N at I is equal to M over R times 1 plus R over M exponent MT minus 1. The fourth formula is S angle N at I is equal to 1 plus I exponent N minus 1 all over I. The fifth formula is that future value is equal to payment times S angle N at I. Sixth formula, we have listed it before. I is equal to R over M, as well as the seventh formula, we have listed it before. N is equal to MT. Okay, let's go to the next one. Is sinking funds. Sinking funds. And in sinking funds, we can have the first formula to be that the payment is equal to future value divided by M times R over 1 plus R over M exponent MT minus 1. The second formula is that the payment is equal to FV times I over 1 plus I exponent N minus 1. We close the bracket. And as usual, our I is equal to R over M, and the fourth one, our N is equal to M times T present value of an ordinary annuity. Okay, the first formula we can have that PV is equal to M times the periodic payment times 1 minus 1 plus R over M exponent negative MT all over R. Okay, number 2, second formula we can have that the present value is periodic payment times 1 minus 1 plus I exponent negative N all over I. The third one, we can have that A angle N at I is equal to M over R times 1 minus 1 plus R over M exponent negative MT. Please, it's better you note all these formulas because we won't write them. We will just be applying them when we begin to solve questions. 1 minus, another formula, 1 minus 1 plus I exponent negative N all over I. The fifth formula we have here is that I is equal to R over M, and the sixth formula is that N is equal to M times T. Okay, so this is the present value of an ordinary annuity. Next one we shall look at is amortization. Amortization. And the first formula we have here is that the periodic payment is equal to present value over M times R over 1 minus 1 plus R over M exponent negative MT. Number 2, periodic payment is equal to present value times I over 1 minus 1 plus I exponent negative N. Then the third one is that I is equal to R over M, and the fourth one is that N is equal to MT. Okay, that is our amortization. So I think we have we've written out all the formulas that we are going to use. We might come across some more as we keep solving questions. You know, business math questions are different. I mean, so if we need more, we shall use it. But for now, this is what we need: the future value of an ordinary annuity, the sinking funds, the present value of an ordinary annuity, and the amortization. Okay, let's go ahead and say what they stand for. All these symbols stand for. FV means the future value or the amount. Okay, means the future value or the amount. PMT means the periodic payment. Okay, I is the rate per period. N is the number of payments, or you can say number of periods, number of payments, or you can say number of periods. PV is the present value of all payments. This is read as A angle N at I, A angle N at I, angle N at I. This one is S, angle N at I. T is the time, and of course our time is in years. Now this future value is in dollars, payments is in dollars, rate per period is kind of a percent per period, okay, because rate is in percent. Present value is in dollars or any currency, any legal tender in your country. T is time in years. R is the annual nominal rate or annual interest rate. We discussed this in the compound interest in percent. M is the number of compounding periods per year, and we talked about this. So please, it is also recommended that you view interest first before you do annuities, because most of the some of the calculations we'll come across here will involve compound interest as well. Okay, you know, this is a kind of note. We are using ordinary annuities. Okay, payments are made at the end of each period. Okay, so this is kind of what we need. Now let's go ahead and solve problems. Okay, let's get started in solving problems. The first question I have here says James contributes 6,000 per year into a traditional IRA, earning interest at the rate of 5% per year, compounded annually every year after age 35 until his retirement at age 65. John contributes $5,000 per year into a Roth IRA, earning interest at the rate of 5% per year, compounded annually for a period of 30 years. The investments of James and John are in a marginal tax bracket of 25% at the time of their retirement. They both wish to withdraw all of the money in their IRAs at retirement. Question I. After all due taxes are paid, who will have the larger amount? Question II. How much larger will that amount be? Okay, so we are, there are some things here that we are going to talk about now. We have what we call the traditional IRA, and then we have the Roth IRA. Okay, we are going to now do some finance. I know you're not finance majors, but if you're a math major, you kind of get to know a little bit of what many majors know about. What is an IRA first? What is an IRA? This is an individual retirement account. You see, math is in kind of almost every field. You see mathematics. There's no way you can solve this question without knowing what IRA means, and what traditional IRA means, and what Roth IRA means. So IRA is an individual retirement account similar to like a savings account that you save for retirement. You make some contributions to that account uh, for retirement. Uh, and one good thing about it is that there are a lot of tax breaks, tax breaks on IRAs. Uh, this is not the same thing as your employer-sponsored 401k. 401k is also a retirement account, but it's different from IRAs. IRAs are kind of personally sponsored, like employee sponsored. Okay. It is good if you invest in IRAs. Let's talk about the two we have here. There are several types of IRAs. We have the traditional IRAs, we have the Roth IRAs, we have the simple IRAs, we have the SEP IRAs. But now we are interested in traditional IRA and Roth IRA. Okay, so let's look at the kind of the about what they mean, traditional IRA and the Roth IRA. Let's start with the differences. With the traditional IRAs, it's kind of it's tax deferred. It's a tax deferred. What we mean here is that when you contribute money, you don't pay tax on the front end, but when you now want to withdraw it, you pay tax. Okay, tax free on front end. Okay, pay taxes on the back end. So that's the main difference here. Okay, with traditional IRAs. Then the Roth IRAs, you kind of, it's not tax deferred. Okay, so that means that you pay taxes on the front end. Okay, pay taxes on front end. You have to pay taxes first, and then it's tax free on back end. So we also have other differences, you know, with a Roth IRA, you can withdraw it at any time without a tax, because it's tax free anytime. Once you pay the taxes at back end, you can withdraw it anytime, tax free. But with a traditional IRA, you must withdraw it at a certain age, when you reach a certain age. Otherwise, you will pay penalty on it. And also, most people are qualified for traditional IRAs, but not everybody is qualified for Roth IRAs. Roth IRAs are kind of restricted to some income limits. Okay. Now, there's something good about both of them. Okay, one thing that is good about both of them is that while your money stays in both accounts, it enjoys growth tax-free. Okay, while it is in both accounts, it enjoys growth tax-free, and the interest is tax-free while it's in those accounts. It's just when you want to now withdraw your traditional IRAs that you have to pay taxes, because you didn't pay tax when you were putting it in. Okay, and we have several other differences, but this is the main thing here. Here you will pay tax when you withdraw it. Okay, here you pay tax up front. Here you won't pay tax up front. It's tax deferred. You just pay taxes when you want to withdraw it. But here you have to pay taxes first, and you can withdraw anytime tax free. There are several other differences, but let's just this is enough for us to solve this question. So now let's look at James. Let's start with James. James is traditional IRA. So that means that when he retires, he will pay the tax. Okay. Now here, the payment he contributes is $6,000 per year. Okay, and the interest rate is 5% per year, which is 5 over 100, which is 0.05. The time, what's the time? He started contributing from 35 until he retires at 60. Okay, from 35 to, until he retires at 65. From age 35 to 65. So time is 30 years. Okay, it's compounded annually. You see it here, compounded annually. So which means that M is 1. Right? Now, he's in a marginal tax bracket of 25% at the time of their retirement. So he's gonna pay this tax of 25%. He will. And the tax is both on the payments and on the interest accrued. Okay, on the payments and on the interest, he will pay this tax. So let's go ahead and find it. Now, this talks about future value of annuity because this is a periodic payment. It is when he now withdraws it, he's making the periodic payments, and when he now wants to withdraw it at retirement, that is the future value. Let's find how much he will get when he wants to withdraw it at age 65, and then we will get his tax. He's gonna pay 25% tax. So let's go ahead and see what this will be. So we have that we are still for James. The future value will be M times payment times 1 plus R over M exponent mt minus 1 all over R. So now the future value will be 1 times 6,000 times 1 plus R is 0.05 over 1 exponent 1 times 30 minus 1 all over 0.05. So the future value will be 1 times 6,000 is 6,000 times 1 plus 0.05 divided by 1. Okay, this is 1 plus 0.05 exponent 1 times 30 is 30, then minus 1 all over 0.05. So let's find how much this guy will have at retirement. So we first of all we have to do this. We'll still use PEMDAS. We're still gonna use PEMDAS. We will do the parentheses, then we do the exponent, then we do minus 1, then we do the division. Okay, we do the bracket first, and inside the bracket we do the parentheses, then we subtract 1, then divided by 0.05, then we multiply by 6,000. So this is 1 plus 0.05 is 1.05 exponent 30, and that is this, then minus 1 gives me this, divided by 0.05 gives me this, times 6,000. Okay, so I've got a 398,633.085. Now 25% tax will be 25 over 100 times 398,633.085. So this is times 0.25, and that gives us 99. So he will pay this tax 99,658.27125. Okay. Take home pay or net pay. Okay, net pay will be 398,633.085 minus 99658.27125. So 398633.085 minus 99658.27125. Please, like I said, don't approximate. If you approximate, you have messed it up. Okay? Please don't approximate until the end. We have talked about it several times. Okay, so this is the thing that James will have. This is amount James. Okay, James. Okay, this is for James. This is the amount he will have, his net pay. All right, now let's go ahead and do for John. Now, John is 5,000 per year, but it's Roth IRA. Okay. So for John, his is a Roth IRA. Roth IRA. That is what he has. His payment is 5,000 per year. His R is the same rate, 0.05. The time is a period of 30 years, just like James. Okay, the only thing is that his own is a Roth IRA. And the M is still compounded annually. M is 1. So we have to look at the future value, which is M times the payment times 1 plus R over M exponent MT minus 1 over R. So the future value will be, now with Roth IRA, John has already paid his tax upfront, and he has paid his 25% tax upfront, and he is now investing the 5,000 into this. So he can withdraw it anytime, tax-free. That is the benefit of Roth IRA. So this is 1 times 5,000 times 1 plus 0.05 over 1 times 30 minus 1 over 0.05. So the future value will be 5,000 times 1 plus 0.05 exponent 30 minus 1 over 0.05. So future value will be, so this is a 1.05 exponent 30, give me this, minus 1, give me this, divided by 0.05, give me this, times 5,000. So I have a 332194.2375. So that's the net pay. The net pay for John will be 332194.24. That's for John. Okay? Yeah. But for James, for James, the net pay will be 298974.81. That's for James. So this is the net pay for James here, and this is the net pay for John, $332,194.24. Okay, so John has more. So John has more. John has more money. Has more. Okay. By how much? By how much? So you now do. You use the, don't come and use the rounded value. No way. I'm not going to use the rounded value. I'm going to use this value. 33194.2375 minus 298974. 298974.8138. Okay, 8138. So when you do that, 332,194.2375 minus 298974.8138, and that gives us 33219.42. So this is the by how much? Yeah, well, it's 0.4237. So approximately, we say that all our calculations, we shall be rounding it up to 2 decimal places. So this is 33219.42. From the videos we did on compound interest, we said we'll be rounding it up to 2 decimal places.